So Dalton's law of partial pressure. The Dalton's law of partial pressure states that the total pressure of a mixture of gases is the sum of the partial pressure of the individual gases. So if you want to get the total pressure of the gases, what you do, you just take the summation of the individual gases in the container. So for example, the P total here is the same thing as P, that is the partial pressure of gas A plus the partial pressure of gas B plus the partial pressure of gas C. So to get the partial pressure of the individual gas, we apply an ideal equation. And this ideal gas equation is, we know that is PV is equal to nRT. So to make VA, which is the partial pressure of gas A, so is something as a number of moles of A times the universal gas constant, which is R, times T divided by volume. And so also, there is also another formula of calculating the partial pressure of an individual gas. So to calculate the partial pressure of individual gas, you can now also say is equal to the mole fraction of A times the total pressure. And mole fractions is the something as what we discussed previously, which says that the mole fraction is the something as a number of moles of A divided by the total number of moles of all the individual gases. And so also the summation of all the partial the mole fractions of all the gases is always equals to unity. And then so here we have an example. A sample of exhaled air contains 4 gases with the following partial pressures. So these are the 4 gases. The nitrogen with a partial pressure of 563 millimeter mercury, oxygen with 118 millimeter mercury, carbon dioxide with 30 millimeter mercury, and then the water molecules with 50 millimeter mercury. Then what is the total pressure of the gas? So it's just to take the summation of all the individual gases. Therefore, you now take the summation of all the four. So you see at the end, we have 761 millimeter mercury.